We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello and welcome to the subject of Basic Civil Engineering, and subject code is 3110004. Myself Kaushal Raval from SHANKERSINH VAGHELA BAPU Institute of Technology, and my today's topic is linear measurement. First of all, we have discussed which topic we will cover in this session. Methods, instrument which is used in chaining, chain surveying, ranging, obstacles, errors in chaining, and tap corrections. Now, first of all, methods of making the linear measurement. There are 3 methods. First one is a direct method, second one is a optical method, and third one is a electronic distance measurement method, that is EDM method. So now, which instrument which is used in a chaining? First one is a chain or a tape, second one is arrows, third one is ranging rods, fourth one is a cross staff, fifth one is a offset rods, and sixth one is a packs, and seven is a plumb bob. These are the necessity instruments which is used in a chain. First one is a chaining. Chain is composed of 100 or 150 pieces of galvanized mild steel wire, 4 mm, which is 4 mm in diameter, called links. The ends of each links are bent into a loop and connected together by means of 3 oval rings. The end of the chain are provided with the handle for dragging the chain on the ground, each wire with a swivel joints, so that the chain can be turned without twisting. The length of the chain is measured from the outside of one handle to the outside of another handle. The following are the various types of chain which is in common used. One is a metric chain, second one is a gunter's chain or a surveyor's chain, third one is an engineer's chain, fourth is a revenue chain, fifth one is a steel band or a band chain. First of all, we have discussed about the metric chain. You see the figure of a metric chain. See the handles and rings over here. See, and the tail is connected together. You can see here. Now, this chain consists of a galvanized mild steel wire of a 4 mm diameter, known as a link. The length of a link is the length between the centers of the 2 central rings provided at both ends of the chain. The chains are made in a length of 20 and 30 meters. Next one is a gunter's chain, or you can say the surveyor's chain. A 66 feet long chain consists of 100 links. Each link of 0.66 feet is known as a gunter's chain. This chain is suitable for taking length in miles and areas in acres. Now, the engineer's chain, it is 100 feet long and it is divided into 100 links. Each link is in 1 feet in length, used in all the engineering surveys. It is used to measure the length in a feet. Next chain is a revenue chain. Revenue chain is commonly used for measuring field in a cadastral survey. It is a 33 feet long and divided into 16 links. Now, the steel bands or a band chain, it consists of a ribbon of a steel with a brass handle at each end. It is a 20 or 30 feet long and 16 mm wide. It is wound on an open steel cross or on the metal rail in the closed case. Brass tallies are fixed at every 5 meter length of the band. Now, testing and adjustment of chain. If chain is found to be a long, so what are the factors to be considered, and if the chain is found to be short, which are the factors is will be considered. Now, first one we have discussed about the if the chain is found to be a long, then closing up the joints of the rings if found to be opened out. Second one is a reshaping the elongated rings. Third one is a replacing the damaged ring if you can find the damaged ring over there, so you have to replace that damaged rings. Remove the one or more small rings if the small rings over there, so we have to remove that the rings. Fifth one is adjusting the links at the end. Okay, once sometimes it will be overlapped to each other, so we have to adjust every time. If chain is found to be short, which are the factors? The factors are straightening the bent links. Second is opening the joints of the rings. Third one is replacing one or more small circular rings by a bigger one. So you just see here, uh, if you find the small circular rings over there, so it will be replaced by the bigger one. Fourth one is inserting a new rings where the necessary, and fifth one is adjusting the links at the end. Okay, so now tap taps are used for the more accurate measurement of the length. There are various types of taps. One is a cloth tap, second one is a metallic tap, third one is steel tap, and fourth one is a invert tap, and fifth one is a fiberglass tap. So among the above, the metallic taps are widely used in a survey. A metallic tap is made of one strip of waterproof line interwoven with a small brass, copper or a bronze wire. These are light in a weight and flexible and are made 2 meter, 5 meter, 10 meter, 20 meter, 30 meter and 50 meter. Now the arrows are made of a good quality hardened steel wire of 4 mm diameter. The arrows are made 400 mm in length, are pointed at one and other end absent into a loop or a circle. Now the ranging rod. The ranging rod are used to range some intermediate point in a surveying line. The length of a ranging rod is either 2 meter or 3 meter. They are stored at the bottom with a heavy iron point. Ranging rods are divided into equal parts, 0.2 meter long, and they are painted alternatively black and white or red and white or red, white and black. When they are at a considerable distance, red and white or a white and yellow flags about 25 centimeter square should be fastened at the top. Now next one is a peg, which is used to fix the station. These are the rods made from the hard timber and tempered at one end, generally 25 mm or 30 mm square, and 150 mm long wooden pegs are used to mark the position of station. Next one is a plumb bob. It is required in order to transfer the points to the ground vertically. Generally, it is used in the centering of theodolite over the station mark. Now, chain surveying. Chain surveying is the type of surveying in which only linear measurements are taken. If we have considered the only and linear measurement, then and then we have to do a chain survey. Chain surveying is also sometimes called as a chain triangulation. You can see here the main survey line, base line over here, check line, tie line. So we have to discuss some definitions regarding the chain surveying. So terms related with the chain surveying. First one is the main stations. taken along the boundary of area as a controlling points are known as a main station. Second is a subsidiary stations. Stations which are on the main survey lines or any other survey lines are known as a subsidiary stations. Third one is a tie station. These are also subsidiary stations taken on the main survey line. Lines joining the tie stations are known as a tie lines. So next one is a baseline. The longest survey line passing through the center of the area to be surveyed is called as the baseline. Check line, the line joining the apex point of a triangle to some fixed point on its base is known as the check line. Third one is a tie line. A tie line which is a line which joins the subsidiary or tie station on the main line. Now we have discussed the operations in chain surveying. So first one is a chaining, second one is a ranging, third one is a offsetting. First of all, chaining. Chaining involves the following operations. First one is fixing the station. We have to fix the station, like suppose we have fixed A to B station, then the unfolding the chain, then we have to do arranging, and fourth one is measuring the distance, and fifth one is folding the chain again. So second one is arranging, the process of establishing intermediate points on a straight line between two service stations in the field is known as ranging. There are two methods of ranging. One is a direct ranging and second one is a indirect ranging. So first of all, direct ranging. Direct ranging is done when the two ends of survey lines are intervisible. So if the stations are intervisible to each other, we have to do the direct ranging. So direct ranging can be done by the two methods. First one is a ranging by eye and second is a ranging by line ranger. Line ranger is the one type of instrument which is used to ranging. See, you can see the figure, the ranging by eye, A, B and C is. So consider the 2 points A and C at the end of the survey line. Distance between A and C is greater than the one chain length. So ranging roads are fixed at the station at A and C. Then the surveyor stands half a meter back side of a ranging road at A and in line with AC. The assistant then goes with another ranging road and establishes the road at A point approximately with the AC. The surveyor at A then signals the assistants to move traverse to the chain line till he is in the line with AC and B. Similarly, other intermediate point can be established easily. By second, the ranging by line ranger. Line ranger is a small instrument. Earlier I told you this thing, used for the establishing the intermediate points in a line with a two distant signal without the necessity of a sighting from one of them. It consists essentially of two reflecting surfaces, either small plane mirrors or square prisms, as shown in figure, one above the other and with that reflecting surface is normal to each other. So for locating the intermediate points are in a line with points A and B. The observer stands approximately in a line and places the instrument on the road, or hold it by eye level, turning it until the image of a road at A is seen in the field of view. He then moves backward or forward at right angles to the line until the image of B appears. One of the mirrors or prisms is commonly made adjustable for the securing the necessary perpendicularly between the reflecting surfaces. Now second one is the indirect ranging, or you can say the reciprocal ranging. Indirect ranging is required under the following situation: when the end and stations are not intervisible due to the rising ground between them, and the distance between the end is too long. So you can see here the A, B, and the intermediate points are M and N. So suppose A and B are to the end of the station, which is not intervisible due to the high ground existing between them. So suppose it is required to be fixed intermediate point between A and B. Two chain men take up the positions at M1 and N1 with a ranging rod. The chainman at M1 stands with his face towards to B so that he can see the ranging rod at N1 and B. Again, the chainman at N1 stands with his face towards to the E so that he can see the ranging rods at M1 and A. Then the chainman crosses the ranging line by directing each other alternatively. And the chainman at A1 directs the chainman at N1 to become the position N2 so that the M1, N2 and B are in the same straight line. Again, the same thing will be happen when the chainman N2 directs the chainman M1 to come to the position M2 so that the N2, M2 and A are in the same straight line. Thus, the two chainmen are now M2 and 2, which is near to be the chain line than the position of M1 and N1. The process is repeated till the points of M and N are located in a way that chainman at M finds the chainman at N in the line. M bend the chainman N finds the chainman at M in the line with NA. Thus the points A, M and B are in the same straight line. You can see the figure over here. There will be the M1 and N1. Again the N1, N2 and M1, M2 and N3 and M3. Now offsetting is the lateral distance measuring the right or left of the chain line to locate the details such as boundaries, building lines, roads and culverts, etc. is called as the offset. So there are two kinds of offsets over there. First one is a perpendicular offset and second is a oblique offset. So perpendicular offset is the lateral measurement taken into right angles. The chain line is called as a perpendicular offset or a right angle offset. An oblique offset is the when the lateral measurement taken is not at a right angle. So the chain line is called as a oblique or a tie line offset. You can see the figure here, the oblique offset and perpendicular offset with the chain line. Now instrument for laying the offsets. Following instruments are used in setting out the right angles. One is a open cross staff, second one is a French cross staff, third one is a adjustable cross staff, fourth one is a optical square, fifth one is a prism square, sixth one is a Indian optical square. Now first of all we have discussed the open cross staff. It is a simple, it consists of two parts. One is a head and other one is a leg. Common type of cross staff, common type of cross staff consists of 4 metal arms with vertical slits for the sighting through. The head is fixed to the top of the iron stands without 1.2 to 1.5 meter long. This is driven into the ground. And for setting the perpendicular lines, one pair of opposite arms is aligned with the chain line. It is specially used for setting off and marking the contour lines. Now the French cross staff. The octagonal cross staff is French cross staff. It consists of an octagonal brass tube with the slits on the all 8 sides. It has an alternate vertical slits and an opposite vertical window with vertical horse air or affine wire on each of the 4 sides. These are used for the setting out right angles. On the other side are vertical slits which are the at 45 degree to those previous mentioned for the setting out the 45 angles. Now the optical square. Optical square is a compact hand instrument which is used to setting out the right angles with a greater accuracy. It consists of a circular box about 5 cm in dia and 1.25 cm in deep, which consists of two mirrors are fitted at right angles. The mirror H called is a horizontal glass which is a half silvered and half uncovered. The mirror I is known as the index glass is known as the wholly as silvered. There are three openings on the sides of box E, B, and C. The opening is pinhole I, and B is a small rectangular slot placed in opposite to pinhole, and C is a large rectangular slot places at right angles to join the line. The surveyor simply turns the optical square upside down and which through the aperture from the object on the side. Now the obstacles like a pond, building, rivers, hedge, etc. prevents the direct measurement of the length, width, etc. between the two stationary two objects. The opticals may be the following type. First one is when ranging is free but vision is obstructed. Second, when the ranging is obstructed but vision is free. Third one is when chaining and vision is both are obstructed. When the chaining is free but vision is obstructed, both hands may be visible from any intermediate point, such as the case of a jungle or a dense plantation. This kind of obstacle may be crossed over by a random line method. You can see here this chain line ACDB is like in a jungle, and we have to find that chain line. So we have to do the random line method. Let the AB is the line whose length is required. Line AB called as a random line. Then chain line BB dash, where BB dash is always taken as a perpendicular to AB dash and measured the BB dash. Then AB is equal to in bracket AB dash square plus AB BB dash square whole raised to 1 by 2. Any intermediate points can be located as C and D on the chain line at AB by taking the perpendicular offset from the chain line AB dash. Now C dash C is equal to B dash B into A dash C divided by AB dash, and similarly D dash E is equal to B dash B into AD dash divided by AB dash. When the changing is obstructed by but vision is free, you can see the figure. When the pawn interrupts the chain line, it is possible to go around the obstructions. AB is the chain line. C and D are the selected on on opposite banks of the pawns. Equal perpendicular CM and DN are erected at a C and D, then distance M and N is measured. Here is CD is equal to MN. Method 2. The pawn may also be crossed by forming the triangle as shown in figure. Therefore, the CD is equal to MD square minus CM square whole raised to 1 by 2. When the chaining and vision both are obstructed, then such a position arises when the building comes across the chain line. AB is a chain line. 2 points M and N are selected on it at one side of a building. Equal perpendiculars M1 and N1 are erected. See, the M1 and N1 is extended until the building is crossed. Then on the extended line 2 points O1 and P1 are selected. You can see here, so that the O1O is equal to P1P is equal to M1N is equal to M1M. then the point M and OP will be on the same straight line AB, and 0 is equal to N1 O1. Errors in chaining. The errors in chainings are classified into compensating errors, cumulative errors, personal mistakes. So first of all, compensating errors. These errors which may occur in either directions and tends to the balance are called as a compensating errors. They do not affect the results much. You have to count it. Cumulative errors. Cumulative errors are which occurs in the same direction and tends to the accumulator are called as a cumulative error, and these errors have a serious effect on the accuracy of survey work. Now the personal mistakes, displacements of arrows, reading of a chain is wrong manner, noting the readings is a wrong way, incorrect counting of numbers of chain, incorrect length of a chain or a tape. Incorrect length of a chain or a tape is always cumulative. If the length of the chain is more, the measured distance will be less and hence the error will be negative. If the length of a chain is short, the measured distance will be more and hence the error will be positive. Now correction to be measured in the length. So I is equal to I dash into L dash by L, where the L is equal to incorrect actual length of a chain or a tab. L dash is equal to true length of a chain or a tab. I dash is equal to measured length of a line, and L is equal to true length of a line. So correction to the area. A is equal to A dash into L dash by L whole raised to square, when A is equal to measured area of a ground, A dash is equal to true area of a ground, L is equal to incorrect actual length of a chain or a tape, L dash is equal to true length of a chain or a tape. Now correction in the volume. So V is equal to V dash into L dash upon L whole raised to 3. So V is equal, when V is equal to true volume, V dash is equal to measured volume, and L is equal to incorrect actual length of a length or a tape, and L dash is equal to true length of a chain or a tape. Now we are going to the tape corrections. Since the tape is not used in a field under the standard condition of temperature, pool, etc. So first one is a correction for absolute length, second one is a correction for temperature, third one is a correction for pool, fourth one is a correction for sag, fifth one is a correction for the slope. First one is a correction for absolute length. The correction for the measured length is given by the formula C is equal to L dash L into C divided by I, where C is equal to correction for absolute length, L dash is equal to measured length of a line, I is equal to standard length of a tape, and C is equal to correction to a tape length. That is the correction for a temperature. It is necessary to apply the correction since the measurements are not made at the temperature at which the tape is standardized. Maybe it will be sometimes it will be temperature will be high, sometimes temperature will be low. So if the temperature is more, the length of temperature increases, and if the temperature is less, the length of tape is decreases. So the formula for the correction Ct is equal to alpha into Tm minus Ts into L, where Ct is equal alpha is equal to coefficient of thermal expansion, Tm is equal to mean temperature in the field during the measurement, Ts is equal to standard temperature for the tap, L is equal to measured length. Now correction for pool. Sometimes if the pool is applied during the measurement more than standardized pool will be applied, the length of tap is increased, measured distance become less, correction is therefore positive. If the pool applied pool during the measurement is less than the standardized pool, the length of tap is decreased, measured distance become more, and correction is therefore negative. The formula for the correction is Cp is equal to Pa minus Ps into L divided by Ae, where Cp is equal to correction for a pool in a meter, Pa is equal to pool applied during the measurement, Ps is equal to the standard pool, L is equal to measured length, and A is equal to the cross sectional area of a tap, and E is equal to modulus of elasticity of the tap material. Now correction for the sag over here. The difference between the horizontal distance and the measured length along the container is called as a sag correction. It is always negative. Now C sag is equal to I upon I1 into WI1 whole square divided by 24 PA square, where the C sag is equal to correction for sag in meter, I1 is equal to distance between support in M, W is equal to weight of a tap in a kg or an N per meter, Pa is equal to pool applied in a kg or a Newton. Thank you very much. Thank you very much to